How does friction contribute to irreversible thermodynamic processes? Imagine pushing a box across a rough floor. You feel resistance, and some of your effort turns into heat. That simple act shows how friction plays a big role in thermodynamics. In thermodynamics, an irreversible process is one that can't simply go backwards without adding extra energy. Think of it like a one-way street. Friction is a key reason why many processes are like that. When two surfaces slide against each other, friction resists their motion. This resistance transforms some of the mechanical energy you use into heat inside the system. This heat isn't just a side effect, it changes the energy balance. It raises the system's internal energy and increases its entropy. Entropy is a measure of disorder, so more heat means more disorder. When entropy increases, the process becomes irreversible because you can't turn that heat back into useful work without extra energy. Let's take a piston moving inside a cylinder. If there's friction between the piston and the walls, part of the work you do to move the piston turns into heat. This heat stays inside the system, making the final state different from the initial one. You can't get all that heat back to do work again without adding energy from outside. That's why friction makes the process irreversible. Friction also causes what we call dissipative work. It's when mechanical energy is lost as heat. Unlike ideal processes where energy is conserved and can be fully recovered, friction always produces entropy. It spreads energy out in a way that can't be reversed naturally. From the point of view of entropy and spontaneity, friction increases entropy because it turns ordered mechanical energy into disordered thermal energy. This aligns with the second law of thermodynamics, which states that total entropy in a system and its surroundings tends to go up in natural processes. In real-world machines and engines, friction limits efficiency. It causes energy losses that can't be recovered easily. Engineers try to reduce friction to make systems more efficient, but some friction is unavoidable. So, in simple terms, friction contributes to irreversibility by converting mechanical energy into heat, increasing entropy, and preventing the process from returning to its original state without extra energy. This is why many natural and man-made processes are inherently irreversible.